Algebra 2 Cram, New York State Algebra 2 Regents, Common Core Radicals. Question 9, simplify a radical expression. Inbox me at memedicine@gmail.com to order your complete Cram session. Review question 9. The expression, the fourth root of 16a raised to 6 times b raised to 4 is equivalent to 1, 2a raised to 2 times b, 2, 4a raised to 2 times b, 3, 2a raised to 3 over 2 times b, or 4, 4a raised to 3 over 2 times b. Definitely press pause if you need to, and I'll give you a moment to think. Okay, so let's take a little conceptual journey through the world of radical expressions and a little bit of exponents, okay? All right, so the nth root of a. This is the expression we're going to work with. So this symbol is called a radical. The n is called the index. And a, the expression beneath the radical symbol, is called the radicand. Now, if n were equivalent to 2, the radical is going to be a square root, and 2 is not written, it's just automatically understood. Okay? Now, if we have this expression, the nth root of c times d, this is a product. Obviously, the radicand here is a product, and it can be re-expressed as the factored version of these products, and each factor can be assigned its own radical symbol or nth root symbol, okay? So if the nth root of c times the nth root of d are both nth roots, they're both equivalent to the nth root of c times d. This is an important concept, and you'll see why in a little bit. And also it's important to note in this case, the radical outputs are going to be non-negative values. And let's just demonstrate why that is up here a little bit more, okay? If this radicand or any of these single expression radicands or monomial term radicands are of this form, if they're in an exponential form, that's some base raised to n, where n is the same value as the index of the radical, and n is also even, this means that the output is going to be the absolute value of a. So it's going to be a non-negative expression, okay? So we're going to take all this mumbo jumbo that I just said, and we're going to apply it to our radical expression. So the first thing that we're going to want to do is we're going to want to factor this radicand into powers of 4 because our index of interest is 4. So we take this and we re-express it. 16 is a perfect fourth root, so it's the fourth root of 2, but we're not going to write that. It's kind of understood. At least you should know that by now. Then we factor a into a. We factor the a term into a raised to 4 times a raised to 2 because we know that when you multiply two exponential expressions of the same base, what you're going to do is add their exponents. So we just subtracted 4 and resolve base a, okay? Then that's going to be multiplied by b raised to the 4th. So what we want to go ahead and do now is apply this concept. We're going to apply the fourth root to each factor of this product, and we end up with this. I'm not going to read everything out for the sake of time. All right. So now what we can obviously cancel out some things. Each fourth root is going to be canceled out with the fourth power. This is obviously 2 to the fourth power. All right, so this root cancels out with this. Not so much this, but this root cancels out with this, okay? And we're going to simply be left with the radicands underneath the radical symbols, except in the case of the fourth root of a raised to 2. But for that particular instance, we're going to apply another concept. We're going to apply this concept that says if you have an index b of a radical raised to a power a, that's equivalent to this exponential expression. So the exponential form of a radical expression is going to be the exponent of the radicand in the numerator of the exponent over the index of the radicand in the denominator of the exponent. So we can re-express this in this form, okay? So here we go. This gave rise to 2, this gave rise to a, and this last monomial here gave rise to b, times a to the 2 over 4, with 2 being the exponent of the radicand and b being the index of the radical. Okay, this can be further simplified if we factor it out 2, and that gives rise to 2ab times a to the 1 over 2. And now we can combine our base a's. If this is automatically a raised to the first power, but it can also be expressed as a raised to the 2 over 2. That's the same thing as a raised to the first power. So we're going to get 3 over 2 when we combine our two a terms, or the two bases of a, because remember, when we multiply two like bases, we're simply going to add their exponent. And the correct answer is going to be answer choice 3, 2a to the 3 over 2b. Thanks for tuning in. Good luck studying.